All right, geometry kids, this is the introduction to transformations, and you're supposed to watch this Monday before you come to class on Tuesday, okay? There's no homework with this, but this is just an introduction. Now, I don't know how many transformations you have done, transformations. In what we're doing, there are basically 5 types of transformations, so this is just an introduction. So a transformation, okay, I'm just going to read this, is a function or a rule, just think of functions as rules, that for every point in the plane, that's, your xy plane, you see the graph paper, as its input, gives or assigns another single point in the plane, f of p, as its output. So those are just some terms. It's really not that scary, okay? But here are some rules. Okay, f of xy becomes x plus 2, y minus 3. Or f of xy becomes 2x, 2y. Or f of xy is negative yx. So we're just going to practice this. We're just going to follow these rules and see if we can figure them out. Okay? So you can read all those words if you want to, but what I'm going to do is I'm going to graph both triangles, okay? So first of all, I am over here in the table, and it says that what I'm supposed to do to the x-coordinate is add 2. So the x-coordinate was 2, so now 2 plus 2 is, I probably should make that a little bit smaller. So 2 plus 2, so that's really the point 4. And here's the y value is 1, 1 minus 3, well, that's negative 2. So that's my new point for negative 2. Now I'm going to do the same thing for b, okay? So b, x is 5, so 5 plus 2, well, that makes 7. Y is 3, 3 minus 3, well, that's 0. And so we're just going to be moving these points around on the coordinate axes. So now c, x is 4, so 4 plus 2 is 6, and 6 is the y, so 6 minus 3 is 3. So now I'm going to graph these points, and before I start graphing them, I kind of look at them, and I noticed I don't really need to make my x and y axis like this, because I don't have much over here with x being negative, so I'm not going to do that. I'm going to put my x-axis closer over here, and I have no idea why this is darker than the others. I'm just going to go with it. 7 is the biggest x value I have. 6 is the biggest y value, and negative 2 is the smallest y value. So I think I can do something like this. Okay? And if we don't mark the squares, we're going to assume that they are 1. So I'm going to make all of these purple. So A is 2, 1. So here's A. 5, so 2, 3, 4, 5. 3, 1, 2, 3. Here's B. And C is 4, 6. So that's 3, 4, 5, 6. So 6 should be here, right? 1, 2, 3, 4, 5, 6. Even though I don't have to put numbers, I often do just because. It helps me graph them correctly. So here's the point, here's the triangle. Oh, not a C. Why is that a 6? It should be C, right? Silly me. C. Okay. So now I'm going to take and I'm going to graph, well, I'll go ahead and use the red. I'm going to graph the ones in red with that. So now A prime, we're going to call it, is 4, negative 2. So this is A prime. That's this point right here. Now I'm going to do 7, 0. So 7, 0, that's this point right here. That's B prime. And C prime is 6, 1, 2, 3. Here's C prime. So there it is. Okay, that's a transformation. I just moved it from one location to another location. That's it. Okay? All right, so here we go. Use the transformation F given to find an image of triangle ABC. Label it A prime, B prime, C prime. Okay, so the first thing I like to do is, what are the coordinates for A, B, and C? Well, A looks like 2, 1, 2, 3. So A looks like 2, 3. B looks like, I know this is 5, so this is 10. So B must be 9, comma 1. And C must be 9, comma 6. Because on these graphs that I stole from eMath, the darker lines are the 5s. Okay, so now I'm supposed to use a new rule, and I'm supposed to negative yx. So so this 3 is my y value. So for my new point, my a prime point, that's going to be negative 3, because I have to take y first and I have to make it negative. And then I just write b. So it's x, right? Which is 2. That didn't make any sense. So now b prime, take your y value, which is 1, make it negative, and then just write x, which is 9. And my c, I'm going to take my y value, and I'm going to call it negative 6, and then just write my x value, which is 9. So now I have to graph these points on the same set. So 1, 2, 3, negative 3, 2. Here's a prime. Negative 1, 9. This is b prime. And c prime is negative 6, 9. C prime, negative 6, 9. This is C prime. So I have a new triangle. It looks a lot like the old triangle, right? Just moved around. Notice looks like the sides are still the same length. It still looks like, well, that looked like an isosceles triangle, still looks like an isosceles triangle. So basically, as I look here, preserves size and shape. That means it's the same size and the same shape before and after. So that's what that means. So this one did preserve size and shape. Okay, when it does that, it's often called a rigid motion, or an isometry is the word, but they don't really say that much on the Regents, but that's what it's called. They do use the words rigid motion a lot, and that means that it doesn't change size, it doesn't get bigger or smaller, and it doesn't get distorted. It's still the same shape. Okay, last ones. So triangle ABC is graphed with the vertices, blah, blah, blah. And then we're just going to practice doing this. So A, they already had for me, negative 4, 5. I'm just going to write them here. B is negative 6, negative 4. And C is 4, negative 4. Okay, so now get it in a different color because I can. I have to do the rule x plus 2 comma negative y. So negative 4 plus 2 is negative 2. 5 just becomes negative 5. That's A prime. B prime, negative 6 plus 2 becomes negative 4. And then I do the opposite of y. Y is negative 4, so positive 4 is what that is going to be. And then C prime, 4 plus 2 is 6, and then negative 4 becomes positive 4. So I'm going to graph these. Here's my origin. I just marked it as 0, 0, but I don't want to put that in there because that'll confuse people. So negative 2, negative 2, negative 5, that would be right here. This is A prime. B prime is negative 4, positive 4, 1, 2, 3, 4. Looks like there's B prime. And C prime looks like 6, 4. Now, I look at this and I say to myself, this is wrong. Why is this wrong? Because look how quirky it's going to look. That can't be right. What did I do wrong? Oh, I did negative 6, 4 when I should have done positive 6, 4. Okay, thanks for catching that, all you that did. So 6, 4 is over here. So here's 6. 1, 2, 3, 4. Here's C prime. Well, that looks a lot better. So now notice my triangle might be upside down, but it's still the same basic shape. I got a straight horizontal line for BC. So that's good. This still doesn't seem right. Is this right? Did I do this right? Negative 4, 4. Negative 6 plus 2. No, that's right. Sorry. Let's try the next one. Gotta do the same. I don't know what I'm doing. I think it's because it's Sunday afternoon. So A again is this. B again is this. All right, when you talk to me on Monday or Tuesday, let me know what mistake I made, because that doesn't look right. Might be right, but doesn't look right, doesn't feel right. Anyway, all right, stop rambling, Struckman, and move on. All right, so A prime is going to be x divided by 2, so negative 4 divided by 2 is negative 2, and then 5 plus 5 is 10. B prime is going to be negative 6 divided by 2, which is negative 3. Negative 4 plus 5 is 1, I think. C prime, I'm very confident in my ability. 4 divided by 2 is 2. Negative 4 plus 5 is 1. Let's try this one. Negative 2, 10. That's A prime. Negative 3, 1. That's B prime. And 2, 1. That's C prime. Oh yeah, this is gonna look funky because we did some multiplying or dividing. As soon as you do multiplying or dividing, things get wacko. So that could be true. All right, did either of them seem like the same size and shape as the question down here answers? Looks like A, right? Transformation A did, or question part A did, right? That did, but this one certainly did not. All right, well, there's no homework, so make sure you watch this, and I'll see you Tuesday or Wednesday. Don't forget, Camo Day.